What's up, guys? Today we're going to be looking at the molecular dynamics, Leonard Jones, and Monte Carlo simulation. Right now it's in the basic Leonard Jones right here. As you can see, number of 50 atoms. We have a bond strength of 1.6 to start, temperature of 5 right in the middle. Um, we also have, so this is the basic, Leonard Jones. Then we can move on to the random, which is the Monte Carlo method. So, just a little overview. This is just more like the molecules move at a random pattern when it's set in this setting. Still the same settings for the number of atoms, bond strength, temperature, but I'm just giving the overview for those two. So the different settings that I'm gonna try today, I'm gonna keep it all the same at 50 number of atoms, 1.6 for bond strength, and temperature at 5 for both the Monte Carlo and the Leonard Jones. Um, and yeah, then I'll move on to put in the number of atoms to 25, um, and put in the temperature higher on the second one, bond strength remaining the same. And then same will be for Monte Carlo and the Leonard Jones one. Okay, so I have started the Leonard Jones already. It's been running for, I'll say, about 15, 20 seconds. Is these molecules started over here? I mean, they've been moving pretty like close together the whole time, not really separating. It's looking like as these are getting cut off, they're moving over here. That's pretty interesting. But yeah, overall, they're just staying together and moving at the same pace. Now we can move on to the random, to the Monte Carlo setup. Okay, so this one's already very different. They're all spread out. We see some atoms, molecules just hitting each other. Over here is pretty empty. They're clustered over here. Now they're starting to move over here. So as the name says, random. This is pretty random. Some molecules just moving faster than others. But once again, this is just the bond, everything pretty even, the temperature and bond strength. Next, we're gonna do the number of atoms to 25 and temperature all the way to 10. Okay, so I just started like 5 seconds ago the Leonard Jones, once again with the 25 atoms and the temperature at 10. It's still pretty the same. Um, I think one little idea that I just had is maybe if I put the temperature all the way up to 10 and me like put in the number of atoms to 25, maybe like it crossed the big effect out. Like if I were to keep the number of atoms to 50 and put the temperature all the way to 10, then I would see a big difference because right now it's not really different from the first trial. They're still together. They're moving a little bit more, which is pretty um which is pretty common, I feel like, because even in real life, when we put temperatures at a higher level, like let's say with water, then it turns into gas, which gas particles are much faster than water molecules, if I'm not mistaken. But yeah, it's still pretty the same. Now we can move on to the random. Let's see how that looks like. Set up. And this is also similar to last time, less molecules. Once again, I mean, I put them down to 25. I cut it by 50%. Um, we see molecules hitting each other, interacting with each other, kicking each other out. A lot of gaps. They're not moving much faster than they were at first, just a little bit, but I think since they have much more space to travel, then it doesn't look like it's all chaotic. So this is what it looks like. Um, I think some inferences or some ideas that I get from like real world implications. I mean, as I mentioned, the water and gas particles earlier. Um, Matter of fact, let me do this because what I'm thinking, what I'm hypothesizing right now is that if since I put this temperature all the way to zero, when I do this random, when I do this Monte Carlo again, then they're gonna stay pretty together. It's not gonna be all over the place. So let's see. Never mind. So they're not together, but they are slower though. Although not much slower. I don't know how that works. Um, Let me see the Leonard Jones setup. And now these aren't moving at all. Okay, so this stays together, stays pretty packed. The random, like the name, is pretty random. So Um, yeah, the this reminds me of like real world, like the ice, like temperature at zero, they stay together, creating ice. But if I were to do it again, like we saw earlier, then it would start moving, water molecules. But yeah, that was the simulation. Thank you for watching.